Welcome to solverfy.
To write balanced equations, given a description, the first step is to find the chemical formulas for each substance and then balance by changing the coefficients. So given the following descriptions, we can do those steps. So for example, if you have lead nitrate solution, reacts with potassium iodine solution, solid lead iodide forms, and potassium nitrate solution remains. To find the formula for lead nitrate, lead 2 means that it is Pb with a charge of 2 plus, and nitrate is NO3 minus. So the formula for lead nitrate to have a neutral compound means that for every lead, there are 2 nitrates. So the formula for lead nitrate is PbNO3. And because it's a solution, we write AQ for aqueous. This is added to potassium iodide. Potassium is the K+1 ion, and iodine is I minus. So the formula for potassium iodide is Ki. And again, this is in solution, so it's AQ. It reacts to form solid lead 2 iodide. So the ionic compound with a charge of Pb2 plus and I minus forms a neutral compound of PbI2 with an S for solid. And potassium nitrate is an ionic compound made from K plus and the polyatomic ion NO3 minus, or KNO3 solution, or AQ. So this is called the skeletal equation, where we take the words and find the formulas for them. The next step is to balance by looking at the number of atoms on both sides. So on this side, we have lead, nitrogen, oxygen, and potassium. And we have the same elements on this side as well. Lead and iodine, nitrogen, oxygen, potassium, and iodine. There's one lead, there are 2 nitrogens because the 2 outside the parentheses multiplies through. So there are 2 nitrogens. There are 2 times 3, or 6 oxygens, 1 potassium, and 1 iodide. On this side, there's 1 lead. There's only 1 nitrogen. There are 3 oxygens, 1 potassium, and 2 iodines. So to balance this equation, we need to change the iodines to 2, which makes that instead of 1, 2 iodines, but it also changes the potassium to 2. So on this side, to balance out, we need to place a 2 here, which gives us 2 potassiums, but also 2 nitrogens and 6 oxygens. And so now the equation is balanced. So the complete balanced equation is PbNO3 AQ plus 2 Ki AQ makes Pbi solid plus 2 KNO3 aqueous. Another example that uses covalent compounds instead of ionic compounds has liquid disilicon hexachloride reacting with water to form silicon dioxide, hydrogen chlorine gas, and hydrogen gas. Covalent compounds, we use the numerical prefixes. So Disilicon hexachloride has silicon in it, which is Si. And the di means there are two of them. Chloride is Cl, hexa means 6. And it's a liquid, so the L reacts with water. No state is given, so we will assume that it's liquid water as well, to form silicon dioxide, which is SiO2, because there are two oxygens, plus hydrogen chloride, HCl, gas, plus hydrogen gas. Hydrogen exists in the elemental form as a diatomic molecule, so it's H2. And then our next step is to balance the equation. So I have silicon, chlorine, hydrogen, and oxygen on both sides. There are 2 silicons, 6 chlorines, 2 hydrogens, and 1 oxygen. Whereas on the products, there is 1, 1, 3, and 2. So to balance, we'll start with the chlorines. Put a 6 here to balance the chlorines, which now gives us 6 plus 2 here, or 8. And we balance the silicons by placing a 2 here, which gives us 2, but an additional 4 oxygens. So to correct that on this side, we put a 4 here for 8 and 4. So the final equation is Si2Cl6 liquid plus 4H2O liquid makes 2SiO2S plus 6HClG plus H2G. And finally, a last example. When nitrogen dioxide is bubbled into water, a solution of nitric acid forms and gaseous nitrogen monoxide is released. Nitrogen dioxide is NO2, and since it's bubbled, that assumes it's a gas, into water, which is a liquid, and it makes nitric acid. The formula for the acids, you should know, and nitric acid is HNO3, and it's a solution, so it's AQ, plus nitrogen monoxide, NO, 1 nitrogen and 1 oxygen, which is a gas. Balancing this is a little tricky because I have 3 oxygens on this side and 4 on this side, so an odd and an even number. But as we work through it, there should be 3 nitrogens here, 2 nitric acids here. And we see that we now have 3 nitrogens on this side and 3 nitrogens on this side, 2 hydrogens, 2 hydrogens, 7 oxygens, and 7 oxygens to balance the equation.